Last episode, we drew the line between a notebook that ran and a service that answers, the model that lives in a variable versus the model that lives somewhere a request can reach it. The first step across that line is humble and easy to skip. Get the model out of memory and onto disk. So here's the question for the next 4 minutes. When you save a model, what exactly do you have to save so it still works tomorrow? A model in a notebook is a Python object holding fitted numbers, and that object dies the moment the kernel restarts. The thing you actually deploy is a file on disk that can be read back into a clean process. The pain we're removing is the one everyone hits once. You retrain, you close the laptop, and Monday you have nothing but a screenshot of the accuracy. But the weights alone are a trap. A loaded model will happily accept the wrong columns in the wrong order and hand you confident garbage because it doesn't remember what you trained it on. So you save the contract too, the input schema and the output meaning, a small dictionary that says 4 features in this order, and the prediction is one of these 3 classes. Then there's the quiet killer, the library version. The serialized file is only guaranteed to load cleanly under the same major version of the library that wrote it. Upgrade scikit-learn 6 months from now, load an old file, and you may get a warning today and a hard failure later. So you write the version down next to the artifact on purpose as data. And none of this counts until you prove it. The only honest test of a saved model is to load it in a fresh state and check that its predictions match the original. Exactly. Same inputs, same outputs, zero drift. If that assertion passes, you have an artifact. If it doesn't, you have a file that merely looks like one. Here's the whole thing in one program. We train a tiny classifier on a fixed dataset, bundle it with its signature and the scikit-learn version into a single dictionary, dump that to disk, reload it, and assert the reloaded model agrees with the original on every prediction. No service yet, just the artifact done right. Up top, we seed everything and train a random forest classifier on the iris data. 4 features, 3 classes, a real fitted model in a few milliseconds. Then we don't just save the model, we wrap it. The artifact dictionary carries the model object, an explicit signature with the input feature names and the output classes, and sclearn version pulled straight from sclearn. Version so the pin is recorded, not remembered. The save itself is one line, joblib.dump artifact model joblib. Joblib is the workhorse here. It handles the big NumPy arrays inside the forest far better than plain pickle, and it's what scikit-learn itself recommends. We dump the whole dictionary, so the contract travels with the weights in a single file. Loading is the mirror image. Joblib load gives the dictionary straight back. We pull the model out of it, and before we trust it, we compare its version pin to the version we're running now. If they differ, we print a loud warning, because that mismatch is exactly the 3 AM page we're trying to avoid. Then the moment of truth, nPortos array equal between the original model's predictions and the reloaded model's predictions. Run it. Training accuracy prints at 1000 on this tiny set. The saved file weighs in under 100 kilobytes. The signature shows 4 input features and 3 output classes. The version pin reads back as the scikit-learn you ran. And the last line says reload identical, true. That true is the episode. Look at the figure and the terminal side by side. The card's saved column and reloaded column show the same prediction for every one of the test samples, and the match count badge equals the assertions pass. Figure, terminal, and headline all say the same number. The artifact is faithful. A model is a file plus its contract plus a version, and a round trip you can prove. Next episode we stop hand-rolling that bookkeeping and let MLflow track every run for us. Sage the 03 MLflow tracking.